Graphing logarithms, I feel like sometimes it's a little scary for students, but they're really not too bad. Remember the basic shape of a logarithm, like if you were going to graph log base b of x, it looks like this. It has an asymptote at 0, a vertical asymptote at 0, and then it curves like that. It's an exponential on its side, really, and it's going to go through 1, because when x is 1, log base b of 1 is always 0. So once you start moving this around, it's not going to go through 1, of course. But the general form, the parent function, would go through 1. We want log base 2 of x minus 4. Well, what this minus 4 is going to do to the graph, this graph right here, is move it 4 to the right. So normally the asymptote for a logarithm is at x equals 0. But if you're shifting it left to right, then the asymptote is going to move. And really the rule is the asymptote is going to be whatever makes this inside 0. So wherever x minus 4 equals 0, that's where the asymptote is going to be. And since x minus 4 is 0 when x is 4, our asymptote, our vertical asymptote, happens when x is 4. Just like that. And it's going to have this same basic shape, so it's going to kind of, I'll draw it real quick. It's going to look something like this guy. All right. But just to be a little bit neater, I'm going to find some points and plot those on there. Just real quick. And here we go. I'm going to choose some x values and get some y values. Here we go. Now, since this is a log base 2, I want to make the inside nice powers of 2. So the easiest one for that to be is to make it 1. Log base 2 of 1 says, if you think about this, log base 2 of 1 equals something. It says 2 to what power is 1. That's what logs mean. So 2 to the 0 power is 1. So when the inside is 1, that happens when x is 5. The output should be 1. The next power of 2 that we can get to easily is 2. 2 to the first. Well, log base 2 of 2 should be 1. 2 to the first is 2. Okay? Oh man, this is a 0 here. I'm sorry. It was 2 to the 0 was 1. Yes. Okay, yeah. 2 to the 0 is 1. Oof, I confused myself there for a second. Okay, this says 2 to the second. Remember, this is our y value over here. Maybe I should write that. That'll make it a little bit easier here. This is our y value. 2 to what power is 2? Well, when y is 1, whatever makes the inside 2. Well, this is x minus 4, so that has to be a 6. The next power of 2 we can do is 4, because that's 2 squared. 2 to what power is 4? Well, 2 squared is 4, so y will be 2 when the inside is 4. Well, that happens when x is 8. And the next one we can do here is 8. 2 to the third power is 8. Okay? That means 2 to the y, which will be 3, will give us 8. So the inside has to be 8 when y is 3, and the x would have to be 12 to make the inside 8. So 12, 3 would be on there. And we can pick a couple fractions if we want to. Like we can raise 2 to a power to get back like a half. 2 to what power is a half? Well, that's negative 1. So to make the inside, so y will be negative 1 when the inside is 1/2. Well, that happens when x is 4.5. When x is 4.5, we get log base 2 of 1/2, and log base 2 of 1/2 is negative 1. Okay, that's probably enough. You can choose a couple more fractions, but you're just going to see that like y will keep getting more and more negative, and the x values get closer and closer to 4, causing this asymptote here. So the points we have right now are 0, 5, 6, 1, 8, 2, and then 12, 3 would be out here somewhere, like that. And we also have 4.5, negative 1, that's right here. And these points, as you go along the asymptote, just get closer and closer to it. So we've got this vertical asymptote happening, and then it's going to curve out like this. And that's what log base 2 of x minus 4 looks like. I didn't do a very good job of hitting these points, but there you go.